If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You're listening to AFM radio on Astronomy.fm. Around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.fm.
The pirates are coming. The pirates are coming. The pirates are coming. You better watch out.
3.
Arr!
Arr!
It's Space Pirate Radio time here on Astronomy.fm. That means it is another Wednesday evening. This one is June the 5th, 2019, 9 o'clock in the evening for those of us here in the eastern portion of North America with daylight savings time. Universal time would put it at 1 o'clock in the morning, Thursday morning, June the 6th, again, of course, 2019. That means we are live, and of course our chat room is happening. Come on over, go to the homepage, astronomy.fm. You'll see how to get into the chat room there. And join us for the evening. We consider you part of our crew when you're in our chat room during our live presentation. So far we get you and me, Diane. We've got Glenn, Twist Edge, Plaid Joan, and Plaid Mac in our chat room. Plenty of room for more. I know it's a tough one when the sun's still up and it's nice out and you're outside doing stuff and come in and even doing watching a TV show while it's daylight. It's kind of tough sometimes. So.
Sure is. Up here in southeastern Michigan, where you and I are based out of, the sun's not even set by 9 o'clock anymore.
That's right. Well, I think it's, what time is it setting? Yeah, right about now, I think. I was going through my Stellarium, which I updated, by the way. I definitely like the updated version. It's got more features to it. But something was messed up with the way my system was set up with the clock and stuff like that. I was off by an hour or two. Says, I thought something was just kind of felt funny the way I was going through some dates and things to see in the sky. And it's like, that doesn't seem right. And I went outside, sun's still up, and went, checked Stellarium and said the sun was down already. It's like, no, that's not right. So pushed a few buttons and got it straightened out now. So some events that were happening. In fact, on our Space Pirate Facebook page, I just put a link to the Jupiter opposition.
Yeah.
Did you see it?
Yeah, and Jupiter is, of course, fabulous right now. Beautiful evening planet, absolutely radiant.
Mm-hmm.
Frankly, both I think and my observing partner Jonathan thinks, you can see it as a disk. It just is not a point of light right now the way that a star is.
Mm-hmm.
In fact, we corralled a colleague from the astronomy club that we're both in Monday night when we were walking to the bar together after our meeting. And, hey, does this look like a point of light? No, it's...
Exactly.
So not only does Jupiter look like a planetary disk, Jupiter's moons are very easy binocular objects right now.
Mm-hmm.
So Ganymede, the largest of them, it's 6th magnitude. It would be a naked eye object in dark skies were it not for being obliterated by Jupiter itself. If you could somehow block out Jupiter, Ganymede would be visible from your typical dark sky site.
Mm-hmm.
And that makes it a really good binocular object.
Yes, definitely. The higher the power, the better, though. But, yeah, you'll start to see the moons just barely below 7 power binoculars. But get up there a little ways, at least 20 power, something small telescope will help a lot better, though. So, during opposition, we have a rare and interesting feature happening with the moon Io.
What's that?
Starting at about 4 o'clock in the morning, our local time Eastern, which is right about 8 o'clock Universal Time on the 10th, Jupiter's moon Io will be superimposed over its own shadow while it's going across the face of Jupiter. And it looks like it's going to stay that way from one edge to the other edge.
Nice.
So it's going to be like a couple hours to go across the face of Jupiter. So that's going to be a good one. Unfortunately, 4 o'clock in the morning is a little bit tough. Just 2 hours to go first. A little bit tough to, I know, get up that early in the morning for us, but it would really be worth seeing and getting some photographs too, because the moon's shadow should be a little bit bigger than Io itself. So you basically should see an opposite of annular eclipse on Jupiter. So you'll see the moon with its dark shadow all the way around it on Jupiter. So that'd be fun. And if you look in our Space Pirate Facebook page, you'll see I put a picture of what it looked like. I used Stellarium, I zoomed in on it, and just screenshot it and got it on there. So. I was trying to remember how to put pictures in our chat room here, but I can't remember. I think you have to put something on a website first, if I recall.
Well, we've got a couple of other things going on with Jupiter at present. One of them is the continued concern over what is happening with Jupiter's Great Red Spot, which has been shrinking to the point where it's described this particular season as having sheets peeling off of it at an alarming clip, raising some concern that it might, after 300 plus years of documented history, finally vanish entirely.
Uh-oh.
And also there's some concern that the southern equatorial belt, the cloud belt in which the Great Red Spot is embedded, may be undergoing its own disappearing act. Now, the southern equatorial belt has disappeared repeatedly, most recently in 2010, and come back. So that's not, that happens. But certainly Jupiter would not be the same visually without that red spot.
Unless it somehow created a reaction in the clouds and snapped up several large spots or another
Which, that could happen. You're quite right there.
Yep. You never know. We don't know, that's for sure.
No, we don't.
Watch it yet. So the red spots, like you said, getting smaller, but it's also seem to be back getting darker again.
Yes, because it had been quite a pale hue for several decades. Not red, more of a salmon spot or a terracotta spot. And it's definitely, while it's condensed, it is certainly redder than it's been in a very long time.
Yes, so a little easier to spot, even though it's a little bit smaller. It is kind of peeling like an onion, though.
Yeah.
The region around it, so but real within it, but around it. So we'll see what happens, and definitely want to keep watching it. We're almost at opposition. That means with the sun setting, Jupiter's rising for pretty much everyone around the world.
Yep.
So,
and this summer it'll be presenting the largest disk that anything bar the sun, the moon, and Venus can present. It is huge.
And of course, for us in the northern hemisphere, it lies close to the southern horizon.
Yeah.
Which means more atmosphere to look through, which means it's harder to get a clear view because of the turbulence of more atmosphere to look through. Just like when Mars is at its best opposition, it's down in that Scorpius region like Jupiter is, and we don't get our best images when it's that far south, looking through that much atmosphere. Southern Hemisphere observers, you're going to be doing real good with Jupiter this year. Have fun with that one. We'll suffer a little bit, but Jupiter's really big anyway, so it's still going to look good. Just going to have to pick your nights very carefully, and your local observing conditions is always. No hot buildings. We have summertime here now, so that's always a hazard. What we need is like one of those kind of a quiet, almost hazy nights where the air is like dead still. And pick a night that just keep trying and see if you can get something that's really nice and steady as far as the air goes. Look at it. You can crank up the power so you can get some really close-up views with it. This is the time when it's really steady. That's when you test your optics. And you experiment with your optics. I've done 800 power on Jupiter before. Well, mostly looking at its moons. But I had like 2 Barlows and a 4mm eyepiece.
That's pretty intense, Marty.
Yeah, looking at some of the moons of Jupiter. And I could see them as a disk. So that was pretty cool. We should see Io as a disk when you see opposition going across the face of Jupiter. So That's a cool one. It's really strange that this must be one dead on, because what I've seen before with Io is that something like the shadow will enter Jupiter first, and then the moon will enter, and then the moon will actually pass its shadow. But this time they're dead locked onto each other. So.
Oh, that is unusual.
So that's gonna be a good one. Optronics just joined us tonight. I want to mention something for Optronics coming up on June the 19th. There will be a lunar occultation of the planet Saturn, and he is in the zone of Buenos Aires, South America. So South Africa, well, it's mostly be daytime event for that, but South America, southern third of South America, will be able to see the occultation of Saturn by the moon, and it looks like it's an evening. Well, no, sorry, my my time schedule was screwed up on Stellarium, so might be later in the evening, or maybe 2 a.m, something like that. I'll have to relook it up before I get off the air, but definitely well placed for South America to see Saturn across the face of the moon. And Saturn's in a pretty good spot in the evening. Well, later in the after midnight times. All right, this is the only one I know that's in South America. Well, let's see. We've talked about this before, the Starlink.
Yep.
All those satellites going across the sky. In fact, some kind of ruined somebody's picture of NDC 5353/54. And there's going to be more added. So now the International Astronomical Union, they just issued a statement saying that they're having concerns about a lot of satellites going into Earth orbit and how it could affect astronomical research. So to
recap, for those of you who didn't tune in the last time we discussed it, SpaceX has launched the first 60 satellites from the Starlink network, which are designed to provide internet service to underserved areas, which is a noble cause. The internet is increasingly, necessary for business, commerce, etc. And ultimately, there's intended to be a constellation of 12,000 of these. So the initial run of 60 has already interfered with the summer astronomy project for the undergraduates at Smith College in New Hampshire in the U.S. And this has raised concern, as Marty said, that what's going to happen when there's 12,000 of these things? So the International Dark Sky Association has voiced their concerns. The IAU has voiced their concerns. It's like, what are you doing, SpaceX? Putting more junk up there. So SpaceX is monitoring the progress of the current 60. They have indicated that they will be reevaluating the future satellites' reflectivity to try to make them less shiny and therefore less intrusive as viewed from the ground. But as of right now, they're not in their final orbit. So they will be raised to an orbit 550 kilometers up, where hopefully even the current highly reflective satellites will be less visible. So hopefully we'll get a better idea. But, in the meantime, given that SpaceX has voiced, oh yeah, we'll fix it, don't worry, in response to the outcry, keep up the outcry. Yeah. They're responding. They're at least listening and saying, hey, don't worry, we'll make them less shiny. So. Oh, less shiny now. So. Yeah. So it pays to make some noise. So when stuff like, it can be less shiny, but when you've got astronomical equipment that can look down to 20-second magnitude. Right. And less shiny means from visible to the eye down to half the brightness of the faintest
stars they could see. It's not dark enough. So I don't know. Can they do it? Maybe. Let's see. Well, I hope they're not planning on one of these. Oops, too late type of things, where I'm sorry, we already launched them and we can't bring them back down, so you'll just have to live with them.
No, I mean the ones that have already been launched, the 60 that have been unleashed, we'll just have to see how they function at a higher altitude. The ones that have not yet been finalized and launched, those might end up being less shiny. Mm-hmm. So we'll just have to see.
Well, that's what I'm saying about maybe something's less shiny, but might be shiny enough, and then it's too late.
Right.
Says, look, we made them less shiny, but they're still too shiny, but now we put them all up there. So I don't know. We'll wait and see, I guess.
Yep.
Unfortunately. Well, we'll hope for the best. Yeah, there's ways of making things less shiny, but not in all wavelengths. You still have infrared cranking out of them. If you paint them all black, then they turn they're highlighted in the infrared. So it's not always optimal. Oh well, we'll see what happens. Yeah. Paint the solar panels black. Well, I don't know, most solar panels are kind of a deep blue actually. But they're usually kind of reflective.
Yeah.
With the clear coat on them.
Yeah. The ones in the ISS, they've appeared red from the ground.
Mm-hmm.
When we've seen them in a telescope when it passes by.
Yeah. Well, I put my name on the 2020 rover.
Oh, that's cool. Yeah, let's talk about the 2020 rover.
Okay. It's called the 2020 rover.
I'm sure it'll get a inspirational name before too long.
Well, anyways, it's going to launch in 2020 or 2024 or something like that. I can't remember. Let me get the article here. So the next rover for the planet Mars is will launch as early as 2020, and then it should reach Mars as early as February 2021. Then. So the idea, for the public part of it, is that like before, you can put your name on it, not with spray paint. Stenciled on chips. Well, that's interesting. Now, do they mean electronically, digitally stenciled? Because in previous missions, they've sent basically, like a recorded chip, and you just got your name digitally added into the data. So stenciled on chips. That'd be kind of cool if they could do it like micro laser.
Yeah.
An actual name, something like that. Well, if you go to the NASA homepage, just type in NASA, you'll see the article for it. You can actually get what's called a boarding pass. They made it a little bit more novel this time. And basically, you don't really fill out the form, but you fill out the boarding pass, which is kind of cool. So the window pops up, and type in your first name, type in your last name, country, postal code, email, and then it says send my name. Hit send my name to Mars, and then you get your boarding pass, and you can actually print it out yourself, which I just did. I didn't look to see how often you could do this. I thought somebody said you could do it once a day or something like that. So,
really?
I have a number for mine, big long, 12-digit number or something like that. So it's kind of cool. I was thinking, I wonder how much they'll accept for like different kind of words on it. If it has to look like it, kind of like an algorithm that could tell if it's not a real name or something like that, like some Facebook stuff. I don't know. Interesting to try, because I wanted to put up maybe something with astronomy.f on it. .fm.
Yeah, so, As far as the construction of the rover goes, it has this week is the week that it is due to have its remote sensing mast, which twin high-definition cameras installed.
Okay.
So it's this very week is the week that it is slated to get its eyes.
Oh, nice.
And the Jet Propulsion Laboratory still says that it will be launching in July of 2020, so a mere 13 months away.
Mm-hmm.
So hopefully it'll stay on track, and we will be having exciting new Mars info within 2 years.
Yeah. Cool. Watch it where it lands, and we're going to get a new landscape, too.
Yeah.
Can't remember. This is not in the water region, is it? The polar region? This one, where's this one going to land?
Let's see.
Trying to remember. There's some talk about
Jezero Crater. I'm not entirely sure where that is.
Okay.
Let's look that up.
Yeah, we'll have to look that one up. A couple of ways of doing a crater mission is like the last one for Curiosity.
Syrtis Major. It's in the Syrtis Major quadrangle.
Okay. Definitely not near the pole then.
Right.
But they usually shoot for one that they suspect has had water in it. Well, with the Mars Reconnaissance Orbiter, they've obviously gotten some incredible images of the surface of Mars and zoomed way in. So if they've got some areas where they suspect that there has been water, like the crater that Curiosity went into, where it has like different layers of shale and stuff like that, they could only be sedimentary type of material, which is always a chance of, if there's going to be any life, might be fossilized in those sedimentary layers, and they might be able to see some of them, especially with the hill up the middle of it. They can basically look at different ages of the water and the dirt that's been in there, so they have a better chance of detecting for microfossils or something, or even something that's still biological in there if it's still moist. So I would assume this is another crater that probably had some, they suspect had some water in it. So we'll see. We'll have to look it up.
Yeah, I mean, it's thought to have been flooded with water. It contains what appears to be a fan delta. So when you think of a river delta, that would obviously be a lot of alluvial soil, deposited soil. So they're thinking that'll be rich in clays.
Mm-hmm.
And it's actually named for it's a Slavic word that means lake. So yes, it's definitely the hint of water is part of the appeal with Jezero or Jezero.
Okay. And also, instead of being a river delta, instead of a crater basin with water in it, that means the river delta stuff has flowed into it from other parts of the planet. So it's like an automatic shipping lane that they're going to be going into. So it's stuff that maybe just happened to get into crater, blew in through the wind or something like that. This stuff would be transported from other regions by river and dumped in different layers in the river delta zone. So if they did find something suspicious of life, then, they still might not know where it came from farther up the river system, but there's definitely a better chance of finding something, because they'll have not just different layers to explore, but different layers that have been transported over time into those areas too. All right, so that'd be a good one to check on too. Another close-up view of Mars. Remember when Mars was just a blurry thing?
No.
But I do.
You're right.
I remember when Mars was just mostly a blurry thing. Through telescope, the red filter, yes, but definitely to darken out some of the green patches. There's definitely some green blobs you can see. Syrtis Major, definitely see the poles. One time observing, I definitely saw Canale. Green lines.
Oh, really?
Green lines, yes. I actually saw what Lowell and the other observers were seeing 100 and some years ago on Mars. Yes, I was able to actually pick out a couple of green lines on Mars itself.
Well, that's what Canale were so compelling. It wasn't just like one or two guys imagined it.
Right.
This was something that hundreds and hundreds of people could see through a telescope.
Yep. But other than that, that was it for Mars, not knowing what it was like down on the surface. I think they had some idea, maybe some of the temperatures. Were able to detect some clouds. But basically, just what did Mars really look like? And then the first probes went there. Was it the Pioneers? I can't remember. The first probes that went by were starting to see some craters, and then they got a dust storm, and so they could only see some of the largest features. So the dust storms cleared, and then they, more and more probes. We got a little bit more detail and a little bit more detail.
Well, we had the Viking lander that appeared at the time to conclusively rule out the possibility of life, but as we've seen over the last 40 years, it's not so conclusive.
Mm-hmm.
As the evidence for liquid water has mounted and mounted and mounted.
So quite a bit of advances. So not only are we seeing high-resolution images of the whole planet from orbit, but obviously some high-resolution images from the surface, mobilely too, not just one part of the surface around a probe, around a lander. But they've been cruising the planet. So
yeah, the MRO, the Mars Reconnaissance Orbiter, has been phenomenal.
It has. There's some awesome images coming out of it.
Yeah, that and the LRO, I think, are two of the underappreciated current space missions in terms of what we've learned and the data that's been collected.
Yeah, I keep forgetting to go to the Lunar Reconnaissance Orbiter pages and check out the detail on the moon, because that is those are some phenomenal images there too.
Yeah,
you get into so much detail that it's overwhelming to go exploring.
Well, when you get to the point where you can see actual like Apollo 14 wheelbarrow tracks.
Uh-huh.
Yeah.
That's some high-res stuff.
Indeed.
Mm-hmm. And let's see, then back to the OSIRIS-REx mission.
Oh, yeah. What you got on that?
They're trying to decide where to pick up a sample at.
Okay.
And they're even inviting the public to help with it. So let me put that in article in our chat room. A lot of citizen stuff, which is kind of nice from the space agencies. All right, so check that out. And these images from OSIRIS-REx of Bennu, the asteroid Bennu, amazing amounts of detail. Well, it's actually, try to imagine going to a landscaping company and there's a big pile of gravel there. So going up to the pile of gravel and you look in it and there's just more and more and more and more. But if you can't touch them and pick them up, that everybody wants to do with cool looking. Oh, there's a cool looking rock. Let's see what it looks like all over it. Nope, can't do that. But we get a super close up view of this like rock pile of an asteroid. This one view, the main view on here, they said the field of view is about 160 feet, and one of the rocks in the upper left-hand corner, it's the lightest one in the photograph, about 24 feet across. That's a big rock.
Yeah, that's a boulder for sure.
Yeah, that's one like a slab you can walk on. It might be, 5 feet up, so that would be an ideal. That's like one you'd want to pick up looking from a picture till you figure out it's the size of a bus.
Yeah.
And then okay, there's some small stuff around here. Well, what size are they going to try to pick up? So they might be looking at it might be looking at an area that has like what looks like sand in this photograph would be mostly pebbles. Or bigger than that.
Okay.
For them to try to pick up. So I see kind of a cool rock near the center, near the top. It's a dark rock with bright speckles on it. That's one I would pick up.
Yeah, it is a cool rock. I can see it in the same photograph.
Mm-hmm.
Yeah.
Now, if you look at look carefully at a lot of these rocks, it looks like let's say a clump of dirt with rocks in it.
Mm-hmm.
And most of the rocks look like that on the surface. And you've got some that are definitely so those look kind of like they're softer. And there's some of them that definitely look like harder rocks because they've got some sharp edges, like a lot of broken up rocks with sharp edges. Again, they're pretty big stuff. But I've noticed a couple different types of rocks on here, and I haven't read any geology reports. It would be kind of fun to see what the geologists have determined from the photographs about what we're actually looking at. So it's mostly dark gray stuff, and then a few light-colored ones. So obviously, what do you go for? The light-colored ones because those are rare, but not necessarily. It might be the dark ones that are rare to geologists, even though they're common on this asteroid.
I agree. The one with the shiny spots looks awfully tantalizing.
Mm-hmm. Everybody likes picking up shiny rocks. And you take them, well, if you don't spit on them right away and pop them up, make them shinier, or you wash them.
Well, not just that, but like with the Apollo astronauts who did selenology on the moon, some of the things that they were looking for were the oddballs, things with a red color or orange color or something that looked like you might have some interesting crystals or whatnot. Mm-hmm. And those were valuable in terms of the data that we got out of them. So yeah, it's like, hey, here's this thing that looks like it has inclusions. All right, let's grab it.
Mm-hmm. Yeah, is it good just to look at, but say, well, you really need to be a geologist to know the difference between is a pretty rock valuable compared to a dull rock, which could be the really rare one that you want to pick up. So.
Well, obviously by the time that you launched a mission, whether it was a manned mission like Apollo, whether it's a robotic sample return mission, you've already done extensive research in your target body. So say with Apollo, they had hypotheses about what the astronauts would find. And in some cases, as when they sent Apollo 16 looking for evidence of volcanic activity, they didn't find any. The data that they got back was no, there was no volcanism here.
Right.
But you at least have a hypothesis going in about what you think you want.
Mm-hmm.
You're not just picking up rocks because they look nice.
They need more pictures too. How are we supposed to pick out, a spot to go pick up stuff with these two images they've got in this article? So maybe there's more articles somewhere if I click on the right spot, but more images, I should say. Did you look at the bottom picture too?
Yeah.
Yep. Interesting kind of squarish rocks. Did you see those?
Yes.
There's two of them I see. One kind of, almost a hollow, like donut square, and the other one's kind of like a letter.
Oh man, don't be calling it food. Then it's going to be like Martian blueberries all over again.
I know. Well, that's just the description. That's nothing.
Right.
Not what I would name it. Yeah, but definitely two like hollow squares are on there, so that's kind of interesting too. Definitely a rock pile and sharp stuff.
Oh yeah, it is a rock pile.
Sharp stuff too, and they're big rocks, so it's going to be kind of hard to get in there. And it makes you the lower picture looks like it's a hill, so it makes you kind of want to climb up that hill.
It does. There's definitely a perception of depth there.
Mm-hmm. It looks really steep, but you got to remember the gravity is like 0.001% of the Earth's gravity or something like that. So you could just pretty much float up. It'd be like walking up a very gentle grade here on Earth. No matter how steep it looks, it'd be effortless to move around on there. I wonder what the gravity is. It's got to be pretty light.
Oh yeah. That's
part of why they picked it, so they can basically just kind of rub the satellite up against it. Be like kind of like picking something off of a wall. Almost like no effort to go grab something and take it away.
In the meantime, we've hit and gone a bit past the bottom of the hour, Marty.
Oh, go for it.
Okay, so you are listening to Space Pirate Radio here on Astronomy FM. Right now we are live with the crew in the chat room, but if you are catching us on a repeat, we will be repeating for the next 24 hours every 4 hours.
Yep.
What have we got coming up afterwards, Marty?
We have Astronomy Ireland What were those other programs? I know we have Naked Astronomers. I think Planetary Radio from the Planetary Society also, and something else too, a different one. We don't have
no Naked Scientists tonight.
I know. Good and bad. Okay, so that's coming up in about another half hour or so. So stay tuned for more programming after Space Pirate Radio. All right, let's see what else have we got. Oh, this image that I just kind of glanced at, it looked pretty cool, but I finally read the detail onto it. It's X-ray image of the night sky.
Okay.
Taken by the NICER instrument on board the International Space Station.
Oh, I think I know the image you mean. Yeah, let's share that baby.
All right, let me put this into our chat room. And I thought, is that what the whole sky looks like? That doesn't seem right. But then I read the article, and it's, well, yes and no type of thing there. Okay, I'll try to describe the image. You can look it up on the NASA website. Mostly dark background with orange swirls all through the whole picture. And some of them look like they're coming out of bright regions.
It looks like air traffic routes.
Yeah, it looks
like air traffic routes coming out of major, highly lit up cities.
Yeah, rusty steel wool type of look to it. So
yeah.
So I couldn't imagine that the whole sky looked like that in X-rays. I would have heard about this before. No, what it is that they were doing images of different objects from the space station with this instrument. And when they moved from one object to another object, when they just pointed from one to another, they did not stop the exposure. It's kind of like star trails. Or star trails, basically when you set your camera up on a tripod and hold the shutter open for hours and hours, the Earth rotates and causes your streaks to trail.
Move. Yeah.
Well, this would be more like having your camera hooked up to a telescope and moving your telescope across the sky by slewing it, moving at a faster speed, and leaving your camera shutter open, so it's constantly taking a picture. So instead of curvy lines going around the North Polar Star, the lines would be going all over the place. Well, that's kind of what happened with this X-ray picture too. They would slew the instrument around the sky, leaving the shutter open, so it was constantly exposing, and those bright X-ray sources were causing streaks to occur in the image. And that was just fine. A lot of times you can actually tell when there's multiple streaks that are kind of parallel to each other. That means, they kind of did some regular patterns from one object to another object, and they did it over several months too. 22 months they were taking these images. So they just basically let it streak. I guess that's the only needed was the points where everything was really focused on. And it didn't really matter if it streaked or not. Maybe they could just remove that information in processing and get the X-ray points in the sky for the technical data that they actually needed. So it kind of made an interesting picture. But if you just look at it, it's a little bit deceptive.
So the primary mission of this NICER instrument is actually to analyze the size of neutron stars. So that's what it's up there for.
Ah.
Yeah.
Okay. By detecting the X-rays coming out of them. Right?
Yeah.
Okay. Or just locating them.
It uses the it also has a pulsar study going on where it uses the timing of the X-ray pulses coming from pulsars, which of course are incredibly precise, to determine its own position and speed in space. NASA's compared it to a galactic GPS system.
Yeah.
So when the hope is that when this technology matures, it would enable spacecraft to navigate themselves outside the solar system.
Mm.
Cool.
Yeah. Let's see. They put together some observations from the Chandra X-ray observatory in space. of different stars, and they were able to detect flares and coronal mass ejection from another star. Yeah, the NASA articles. The NASA article is pretty light. Let me put one from another source. Here it is. I think from this is an abstract from Nature Astronomy. I'll put a link to that. You can read about it. So they weren't actually seeing flares. They're detecting flares and coronal mass ejections from the star. Let me put the article in here. And they were doing that by spectra.
Oh, okay.
Measuring the spectra, and I think it was the intensity of the light. Oh, they were actually able to see the Doppler shift in the spectra.
Very cool.
Yeah, so they could actually tell if then all of a sudden, like some spectral lines. Let's see, S is sulfur. Is that right?
Yes.
Sulfur. Si is silicon.
Yep.
And magnesium.
Okay.
Ionized lines of that, and they could see that they were actually indicate the lines that indicated that there were actually upward and downward motions in those lines. So flares will do that. Flares will, basically come towards you when they're flaring up, and then they will come back down towards the star. So you get a blue shift and then a red shift. And using other lines like oxygen line, and was it just oxygen? They also detected a blue shift in the O8 line. That's 8 times ionized oxygen. That revealed an upward motion, and that was the cool plasma. That was the CME coming within after the flare. So that's how they did. They did not see this star just like blast in brightness and flare up and stuff like that. No, they detected it chemically, looking at the spectra. So they're actually able to detect a flare on another star and coronal mass ejection. Let's see. We already did Jupiter. Bright star occultations, just a couple of them in the month of June. One coming up in Gemini. That'll be happening. Remember, Gemini is really close to the moon, so that's towards the west on the 6th. So that's technically today or tomorrow, depending what time it happens. Then on June 18th and the 21st, one will be in Sagittarius and Delta Capricorn on the 21st. 18th one is visible from southern Australia, and 21st one visible from South Africa and South Australia. So the moon's pretty low for us this time of year. Meteor showers. Gone through a couple already, but coming up on June the 8th is the June-Me Cassiopeids, and the June 8th daytime Aretids, which is kind of a cool one. Let me go back to did I miss it? Where's spaceweather.com had a decent article on this one. Go to spaceweather.com and check out the article on the daytime Aretids. It's not as bad as it sounds. These things are coming from the sun because, not quite from the sun, but kind of a little bit off from the sun, a few degrees off from the sun. So there's a chance of seeing them super early in the morning, just before sunrises. There's that article. There we go. Go to spaceweather.com. We'll put the article in our chat room. It's easy enough to find. So you might be able to see some just before sunrise, while there's still some, enough darkness in the sky.
Okay.
To be able to see them. They'll be, streaking pretty low.
And they will be peaking tomorrow, so June 7th.
Yeah.
Interesting.
Yep. So you got a chance of being able to actually see some of these skimming across the sky. Maybe early in the morning. This might actually have maybe some bright ones, but mostly there's a lot of them. This is almost a meteor storm. Most of the observations they're doing is using radar. and they're picking up. Well, they expect 20 every second. No, 1 every 20 seconds. Sorry, so three.
Okay,
Three every.
yeah, 20 every second would be a legendary meteor storm.
Yeah, that would be, even though we sort of wouldn't see it. So it's mostly in the daytime. It's still really possible. So if you could be out in the morning of the 7th, outside, you might just want to like keep scanning the skies, get your phone ready, take a picture, because if we get one of those that is a big chunk, it could actually be seen in the daytime sky.
Wow.
Yeah, that's always possible. Never know what's inside of a meteor shower, but this is one. If you don't see it at nighttime, let's try it in the daytime. You never know what you might be able to see. Something might still pop up, or even better yet, like an all sky camera system. Record it during the daytime this time and see what happens. And what else is coming up? Let's see, the Zeta Perseids peak on June the 13th. And then another one, the Beta Taurids on June the 29th. The Beta Taurids are the ones that they think is associated with the Tunguska event.
Oh, okay.
Mm-hmm. Let's see. This June, the Taurid debris swarm, they're calling it, will make its close approach to Earth since 1975. So definitely want to check that one out. And maybe there'll be some big ones. Again, if you got an all-sky camera, GoPros, something like that, you might want to have that running during that storm. I don't think that's a regular evening one. Because Taurus, well, I don't know. Taurus, the sun's in Taurus right now.
Yeah, Taurus is gone, baby gone, as far as the nighttime sky goes.
Mm-hmm. So that might be another. Is that another daytime-ish one? I don't know. They don't call it a daytime-ish one. Maybe it's far enough from the sun that's just going to be like an early morning one then.
So we've got a little update on NASA's InSight probe, which is right now on Mars. Its heat probe, a.k.a. the mole, is that self-hammering spike designed to go 5 meters below the surface and record the temperature. But it's been kind of stuck since the end of February. So they're trying some new techniques to try to get the mole up and running again. They suspect that the likely cause is an unexpected lack of friction in the soil around InSight, which is very different from the soil seen elsewhere by the rovers sent to Mars. So the mole was designed with that known quantity of soil in mind, so that the friction would work against its recoil and allow it to dig. Without the friction, it bounces in place.
Ah,
yeah.
I've done stuff like this.
Yeah.
Try hammering a nail into a board while you're holding the board in your hand. It bounces away. So when you put the board down on something solid, then you can hammer it and it goes right in. But if the board's not attached to anything, it flexes and absorbs the hits and it doesn't go in. So I understand what's going wrong with that drill.
Yeah, so they're trying to account for that friction to get the mole up and running again, so InSight can do what it needs to do.
If you pull on it, it has the same flexibility and it twists a little bit and it sticks. Yes, quite familiar with those types of issues. Let's see, got a ton of articles to talk about. I like this one. A cool nebulous ring discovered around A star, Sagittarius A star.
Ooh, which
super
of course
massive.
Is not a star.
Exactly.
It's the black hole at the center of our galaxy.
That's right. So let me put this article in here. I'll talk about what's. Where did that article go?
Nebulous ring around the black hole. So we were just at an astronomy club meeting on Monday. We were just talking about black hole science and the way that the rotation of the black hole, of this particular black hole, Sagittarius A star, was charted by the movements of the stars around it.
Mm-hmm.
So this is yet another layer of interesting stuff going on there. So this is coming out of ALMA, the network of massive telescopes down in South America.
Radio telescopes.
Yep, radio telescopes specifically. So yeah, interesting.
Yeah, so
The
more.
gases are expected to orbit the black hole in an accretion disk that extends a few tenths of a light year from the event horizon. Yeah, because that was something cool that we discussed at the meeting the other night, is when they calculate the event horizon of a black hole, it's not really as big as you would think, because black holes are small. Even supermassive ones are small.
Mm-hmm.
So a couple tenths of a light year from the black hole's event horizon, that's pretty big.
Mm-hmm. Mm-hmm.
Wow.
That's a cool one.
Yeah, very.
Let's see what else we got going here. Oh, I know what. I just looked this one up. Just happened to cruise the European Space Agency's website.
Okay.
And see what they're doing, and it just discovered something I haven't read about before. I know it's been up there for a little bit. Space Rider.
Yeah.
And Vega C. Vega C is their a launch vehicle that they're planning on, and Space Rider
Sounds like a 1970s TV show.
It does, but it makes sense because it's like an unmanned half of a space shuttle.
Yeah?
Yes. Let me put this article into
Yeah.
our...
Let me see this thing.
All right, here you go. So, yes, it's made for go up into space with experiments, and as cargo.
Okay.
And then come back down and land.
Uncrewed high-tech space laboratory operating for periods longer than 2 months in low orbit. Okay.
The shape of it looks like, well, at least I know it looks like what I see, it looks like a lift body type of design, where it looks like it'll basically glide in with heat shields on the bottom, glide in like an airplane. I don't know what kind of landing system it has. I haven't read that article that much, but designed to land in close.
Okay, so it's an adaptation of the Intermediate Experimental Vehicle, aka the IXV, which is another ESA craft that flew a flawless mission back in 2015.
Mm-hmm.
So it builds on that, adding a cargo bay, a landing gear, an upgraded design to guarantee reusability for an additional 5 flights.
Mm-hmm.
So this isn't intended to be a good for 100 flights in space, but is intended to be reusable. That's quite interesting.
Yep, and the main thing is to bring its own instruments back down.
Yeah.
So it'd be interesting to see how much more they put into it. I know as time goes on, they'll obviously going to try to put more and more stuff into it. Will it have a robot arm? That'd be interesting if it does, something like that. So
Little mini Canada arm, that'd be cool.
Mm-hmm. A launch bay maybe where they can bring satellites up and send them out into space. So we'll see. So just happened to glance at the ESA's website and saw that. So we'll look forward to more advances from them.
So we started the night with a piece that was a little bit critical of SpaceX, or at least dubious about SpaceX and what they're up to with launching the Starlink network. This is slightly more optimistic spin on first U.S. astronauts chosen to fly aboard a SpaceX capsule. So two of these, so the 2 space shuttle veterans, Bob Behnken and Doug Hurley. Hurley you might know, even if you're not eyeballs deep in the shuttle program, because he was the pilot for the final mission of the shuttle Atlantis back in 2011. So they are scheduled to lift off this year from Cape Canaveral in the debut manned flight of the Crew Dragon, along with 2 fellow astronauts, Mike Hopkins and Victor Glover, who are hopefully being launched at a later date. So this is all systems go. They're on track. It's going to happen.
Mm-hmm.
And, of course, given some of the mishaps that SpaceX has experienced, the astronauts are questioning, like, hey, how you feel about this? So Hurley said, people to a degree think it's pretty glamorous to be able to go into space, but it's actually like a messy camping trip. So this is what he told Reuters in a recent interview that took place at the Johnson Space Center. So he's not worried. He's already flown the most complex thing that mankind has ever designed, and whatever SpaceX has in store, he is on board with it.
You said he called it a messy camping trip?
Messy camping trip, yeah.
I do that all the time. All my camping trips are pretty messy. In fact, what I usually do when I pack for something like that, I make a list, and then I start piling stuff like in the living room or on the couch. And then when I'm ready to go, I take that pile, move it into the vehicle, and then I go. And when I get there, I sort through it all. So I don't actually sort through it beforehand. I just hope to have enough stuff, and I don't pack neatly or anything like that so I can find it by opening the cart. No, I go through it, pull everything out, and then I sort through it. So, what a coincidence. I'm qualified for a space program.
Ha!
Because I'm messy. I can relate. 4 more minutes. Okay, what did I have? Something. I thought I had another article on. I know. How do you pronounce this mineral? Molybdenum.
Molybdenum.
Molybdenum. Okay. Molybdenum.
Yeah.
I got it. Okay. I'll put this article in our chat room just for you. Then you could read through it. It mentions that mineral. I like molybdenum better.
I used to. Okay, so I had a chemistry teacher in high school, and he had a weird little joke. And I don't even know if it counts as a joke because it wasn't funny so much. It was just strange.
Okay.
But so his little fantasy life involved Roy G. Biv. So that's the old spectrum, including indigo, red, orange, yellow. So Roy G. Biv and his girlfriend, Molybdenum or Molybdenum. And they had a dog. Can you guess what the dog's name was?
Pluto.
Whoa. Piblo.
Piblo?
Piblo. PVI. Yeah.
Okay.
Yeah. From the PVI equation. Yeah. He's a chemistry geek. It was just struck me as weird because he took such delight in imagining the adventures of Roy G. Biv and Molybdenum and the dog.
But after all of that,
Pib
you
nerd.
remembered it,
Sorry,
though, didn't
Pib
you?
nerd. Yeah, Pib nerd. Yeah.
So that was kind of an effective way of.
Oh, it was. I was really glad to have him because the other chemistry teacher in my school was the football coach, and nobody learned anything.
Mm-hmm.
So, yeah, I had the functional chemistry teacher.
All right. So, okay, here's a little geologist joke. What kind of mineral do you think about when you're hungry?
I don't know. What?
Apatite?
Ugh.
Does it look like appetite?
Ugh.
There you go.
Bad.
I know. That's why we're here. All right. Less than 2 minutes. I think this is, let me take this, send this to you real quick here. It doesn't, it's the natural, wait, here, let me click on the article here. All right, coming at you, so I could hear into a chat room. Check this out. And where's it coming? Let's go. One more.
One last word before we sail off.
One last word.
Oh, how Sphere helps protect the Earth from dangerous asteroids. Okay.
Yeah, this double asteroid, is that the one this is the one that just flew by, didn't it? Okay.
Sure did.
Just wanted to make sure. And they've got the, now I'm trying to,
Yep.
okay, the one on the right is an artist's impression, and the best image that they got, basically, I think with radar, was the one on the left. Is that radar? EL, Very Large Telescope?
Radio, I thought.
Maybe it's visible. Well, anyways, you can see what it looks like. Double asteroid, sort of blobby. That's it. And it is time for us to get out of here. So don't forget, more programming coming up. I want to thank everybody in our chat room tonight. Really appreciate you all being here. And see you next week. Good night, all.
Clear skies, y'all.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.